Okay, so this one is the continuation of the previous video we had. So let's do this together now. So we are going to apply second Newton's law of motion using their conditions for the first body diagram. So like from this free body diagram, we're going to use the conditions. So here, by using these conditions, we're going to use Newton's second law of motion. As this object was moving in a vertical direction. So we're going to say, as this object was moving in a vertical direction, so we're going to give it a summation of y being equal to mass 1 times acceleration. And you know that force is equal to mass times acceleration. Where there is force, like for this one, force is depending on mass and also acceleration. So this is how we're going to go about this problem. Let's follow it together so nicely. So we know that as this object was moving, we had tension, and this tension was the one which was pulling the pull of gravity, or rather was the one which was pulling the weight. So tension is going to pull out the weight. So weight is what? Mass 1 times gravity, being equal to mass 1 times acceleration. So this one becomes our equation number 1. Okay, like so here we're going to continue. So from the free body diagram, we're going to use again Newton's second law of motion to identify the path that you are supposed to undergo about this free body diagram. So here we're going to use the conditions of equilibrium. So by using the condition of equilibrium, we are going to say this object was moving in x direction. So here we're going to say, okay, the summation of force x is being equal to mass 2 times acceleration. So we are going to identify now the path on how this was moving. So how was it moving? So this one was moving in the direction, okay, like it was pulling. Now, which side was pulling this ball? The side which was pulling the ball, it was the force of gravity. As this box was moving, it was being pulled by the force of gravity. So the force of gravity here, it's mass 2 times this sine theta. So this one was the one which was pulling the ball. So what was being pulled here? The things which were put here, it was 1, the tension, and then 2, the kinetic friction. So the kinetic friction here, it was being put as well. And then what else? This one is the same as mass 2 times acceleration. So this is how you're supposed to identify the path on how to undergo this problem. And we know that the kinetic friction is equal to the normal force. So how are we going to identify? So the first thing that you're supposed to do, you're supposed to identify this kinetic friction. So the kinetic friction is equal to mu, which is constant, times the normal force. And then you know that the normal force is equal to the force, like to the pull of gravity. So what is this pull of gravity here? The pull of gravity here for the normal force is m2 g cos theta. So like this one is the same as the normal force. So this one, as I've already said, is equal to the normal force. Okay. So then the next thing that we are supposed to do here, this is what we are supposed to do. Since we've known now that the normal force is equal to this, so this is the next step that you're supposed to do. So here you're supposed to write everything that we've presented so far. We said that m2 g sine theta minus tension. Tension was being put minus, you open bracket, and then you know that this, what we've opened for the bracket, is the values for the friction. So the friction value we're going to have here, we're going to have mu m2 g cos theta being equal to m2 a. So this one becomes our equation number 2, since the question they've told us to find the acceleration as well as the tension. So this one becomes our equation number 2. So from these two equations, we are going to add them together equation number 2 and equation number 1. So by adding them together, we are going to equate them. So this is what we are going to do by equating them. So we're going to say for equation number 1, we have tension minus m1 times gravity being equal to m1 times acceleration. So this was our equation number 1. So for equation number 2, we have m2g sine theta minus tension minus mu m2g cos theta being equal to m2 times acceleration. So we're going to solve them simultaneously. So by solving this simultaneously, we can make the equation number 1, like tension, to be the subject of the formula. So by making tension to be the subject of the formula on the equation number 1, so it's going to be look like this. Tension is equal to m1 times acceleration plus m1 times gravity. So this is our equation number 1. Now where are we going to take it? We are going to substitute it into our equation number 2. So our equation number 2, as we've already given emphasis, is m2g sine theta minus t minus mu m2 cos theta being equal to m2 times acceleration. So here where there is t, we're going to substitute this. This value here where there is t. Here we're going to substitute all of this. So this is how it's going to look like. So we're going to have the values like this. We're going to have m2 g sine theta. Let me do this. Okay, m2 g sine theta minus, what are the values that we've made to be the sub of the formula? We've made that m1g plus m2 m1a, sorry, m1a minus mu m2 g cos theta being equal to m2 times acceleration. So this is how our equation is going to be. After all these steps, we're going to make acceleration to be the sub of the formula. So by making acceleration to be the sub of the formula, we're going to have something like A is equal to m1 plus m2 being equal to m2 times gravity sine theta minus m1g minus mu m2g cos theta. So this is what we are going to have. So at the end of the day, we're going to have something like this. We're going to have something like this. So our acceleration is going to be like acceleration being equal to m2g sine theta minus m1g minus mu m2g cos theta over m1 plus m2. So here, this is our final part for us to find acceleration. So on how we're going to go about this, we know that we are given values for all these identified parts. So we're going to substitute now those values for these identified parts so far. We are given that mass 1 is equal to 2 kilograms, and we're also given that mass 2 is equal to 10 kilograms, and we're also given that the angle theta was 37 degrees. So these are the items, or rather the values, that we are going to substitute in those given problem. So by substituting, we're going to our values here, we're going to have acceleration. So acceleration is going to be acceleration being equal to, what is m2? M2, we say that it's 10. What is the gravitational force? The gravitational force is 9.8. Okay, sine, what is our angle? Our angle is 37 degrees. Okay, minus, what is the mass? M1 mass. M1 mass, we say that it's 2 kilograms, having our gravitational force of 9.8 minus, what is our mu now? The constant value, or the kinetic friction constant value, it's 0.25, having our mass of 10, gravitational force 9.8 cos 37 degrees. Remember, we are supposed to divide everything by mass 1 plus mass 2. So what is mass 1? Mass 1, we said it's 2 plus 10. So when you add these, you're going to get 12. So our final answer here, when you punch everything on the calculator, we're going to have acceleration being equal to 1.65 meters per square second, seconds. So this one becomes our value for acceleration. Okay, so here we're going to continue. Since we know now the value for acceleration, so what we are supposed to do here, we're supposed to find the value for tension. So how are we going to find the value for tension? We know that from the equation number 1, we've made tension to be the subject of the formula. So we're going to get that equation, we've made tension to be the subject of the formula, where tension is got m1g plus m1a. So here we know the values of m1, and we also know the value of acceleration, because the acceleration here we've already found it. So how are we going to go about it? So this is how we're going to go about it. We're going to substitute the values that we have here, and then when we punch our calculator, that will be the solution for the tension. So when you substitute these values, we're going to have, what is m1? M1 it's 2 times, what is gravity? Gravity it's 9.8 plus m1 again, it's 2. What is acceleration? Acceleration is 1.65 meters per square seconds. So when you punch your calculator, adding them together, we are going to have tension to be 22.9 Newton. So this one becomes your tension. Then you are going to conclude by saying, therefore, acceleration is 1.65 meters per square seconds, and tension is equal to 22.9 Newton. So this is how you're supposed to go about this question. Thank you so much.